All right, here we go. And welcome back to the Yes Functional Longevity Podcast, where we give you insight on how to get fit, feel younger, and live better. Good afternoon. My name is Chris Borda, best-selling author and owner of Yes Fitness, coming to you from a snowy day in Burlington. One of the few snow days so far this year in 2023. I don't mind. It's kept down costs, heating costs. We know they're skyrocketing this year. So before we get too far into this, I want to thank you for taking the time to listen to what I have to say this afternoon. I'm hopeful that it's helpful you and interesting and something you can utilize to live longer, healthier lives. And just a little bit of housekeeping. If you would like to listen to this broadcast, you can listen to it anywhere you normally listen to your podcast, Apple Music, Spotify, wherever it might be. If you want to get a copy of the transcript or a timestamp, you can head on over to yesfitnessct.com, scroll down to where it says podcast, and click on whatever one of our 235 broadcasts to get whatever information you're looking for. So let's just jump right into this today. We're going to be talking about proven ways to power our cells to help fight devastating disease, something that we should all want to do. And if we're not doing this, you will be likely to get some of the diseases we're going to talk about today. So we've been going through the different hallmarks of aging. We're now on to stage 2. We're talking about one of the antagonistic hallmarks, the second stage. If you don't remember, if you didn't listen to last week, it is aging that can be characterized as responses to the cellular damage caused by the primary hallmarks. That's what secondary hallmark of aging is. And we're going to touch on number 6 of the hallmarks of aging, mitochondrial dysfunction. And it's super important. It's a condition that affects the energy-producing powerhouses of our cells and how it can age the body, how this ages the body. Plus, we're going to talk about how you can slow mitochondrial dysfunction. So mitochondria, if you've back in biology class in high school, are the powerhouses of our cells. They metabolize the nutrients consumed to create energy for the cells, producing about around 90% of this energy cells need to survive. They're tiny structures within our cells that are responsible for producing the energy for which we need to survive. They convert the food we eat into a form of energy that the cells can use. Think of a cell like a city. The city has lots of parts to be powered, to keep it functioning. And the cells have lots of little organelles that need power to keep the cell functioning. So the mitochondria are the power plants that provide the power for both the city and the cell. So mitochondrial dysfunction refers to a condition in which mitochondria, sometimes again referred to as a powerhouse of the cells, responsible for generating energy, they are not functioning properly. And this can lead to a variety of health problems, including fatigue, muscle weakness, and even organ damage. We're going to go through some of the other health risks in a few minutes. As well as providing energy for the cells, mitochondria also are responsible for breaking down waste, producing chemicals for signaling and cell apoptosis. Now, apoptosis is the process of programmed cell death. We want the cells to die eventually, and it's an important process. And it is used during early development of eliminating unwanted cells. In adults, apoptosis is used to rid the body of cells that have been damaged beyond repair. Apoptosis also plays a role in preventing cancer. If apoptosis is for some reason prevented, it can lead to uncontrolled cell division and the subsequent development of tumors, heart disease, cardiovascular disease, metabolic disorder, Alzheimer's, Parkinson's, cancer, all kinds of diseases. So we want this to happen. In these diseases, the malfunction of mitochondria contributes to the progressive degeneration of tissues and organs. And as we age, mitochondria become less functional, providing less energy, less efficiently, and releasing harmful reactive oxygen species. Now, according to a study published in 2018, reactive oxygen species cause DNA mutations, inhibiting proteostasis, which we discussed last week, and accelerate sarcopenia, which we know is the loss of tissue as we age, and suppresses the immune system. All bad things that can happen to us. One of the key factors that contribute to mitochondrial dysfunction is oxidative stress. This occurs when an imbalance between the production of free radicals and the body's ability to neutralize them with antioxidants. Free radicals can damage the DNA, proteins, and lipids within our cells, leading to inflammation and cellular damage. Several factors can contribute to mitochondrial dysfunction and accelerating the aging process. These include exposure to environmental toxins, a sedentary lifestyle, a diet high in saturated fats and sugar, and chronic stress. All things we know we need to stay away from, right? Mitochondrial dysfunction can also be caused by genetic mutations that affect the structure or function of the mitochondria. Other factors that contribute to mitochondrial dysfunction is mitochondrial DNA damage. Now, unlike the DNA within our cell's nucleus, mitochondrial DNA is not protected by histones, which are proteins that help keep our DNA stable. This means that mitochondrial DNA is more vulnerable to damage from free radicals and other environmental toxins, which can lead to mutation in electrons within the mitochondrial genome. So it's not the best thing to do to have mitochondrial dysfunction. So how can we prevent it? And how can we promote good health again? One strategy, as you might imagine, is to eat a healthy diet rich in antioxidants such as fruits and vegetables. Antioxidants can help neutralize free radicals and reduce oxidative stress within our cells. You got to take in a whole lot of fruits and vegetables, a whole lot of antioxidants for it to happen there. But as always, it's good to have a good, solid diet, a nice, healthy diet. Certain supplements and nutrients such as CoQ10, alpha lipoic acid, acetylene L-carnitine have been shown to improve mitochondrial function and reduce symptoms of mitochondrial dysfunction completely. To uphold the functionality of mitochondria, increasing NAD plus through supplementation or lifestyle alterations has also been shown in research to slow down mitochondrial damage. We've talked about NAD a few times. And one such lifestyle alteration involves increasing your amount of physical activity. You know, you should always get back to exercise. Exercise charges the battery of the mitochondria. A study published in the journal Diabetes found that individuals who regularly exercise had boosted mitochondrial function compared to those who were sedentary. And exercise has been shown to have several benefits for people with mitochondrial dysfunction, including improved mitochondrial function, which we just said. Regular exercise increases the number and the function of mitochondria in our cells, which can improve energy production and reduce symptoms of mitochondrial dysfunction. The more mitochondria you can have in a cell, the healthier they are, the less likely we're going to have dysfunction. It increased circulation. So exercise improves circulation. We can help deliver more oxygen and nutrients to the cells, including mitochondria, and remove waste products. A third thing is help reduce inflammation. Chronic inflammation is often associated with mitochondrial dysfunction, and exercise has been shown to have anti-inflammatory effects, which can help reduce damage to the mitochondria. A fourth way is improved glucose metabolism. We talked about glucose intolerance recently. So, exercise improves glucose metabolism and insulin sensitivity, which can help to reduce the risk of developing mitochondrial dysfunction and other metabolic disorders. For example, diabetes, something no one wants to get. And the fifth one is increased antioxidant capacity. Exercise has been shown to increase the body's production of antioxidants, which can help to prevent mitochondria from damage caused by free radicals. Overall, regular exercise can be an important part to manage mitochondrial function and improve overall health. That exercise being both cardiovascular and strength training. Let's get the muscles pumping. Let's get the blood flowing. Let's push and try to build more mitochondria in our cells. Let's increase our NAD plus to become healthier. We live longer, healthier lives. Be able to enjoy those lives, especially if we're doing some strength training. So there you have it. Number 6, mitochondrial dysfunction. Exercise, nutrition, stress reduction, all the things we talk about all the time that will just help you live longer, healthier lives. If you need any help with this, certainly get a hold of me. If you have any questions, get a hold of me. I'm probably going to be a link in the notes where you can jump on and head on over to yesfitnessct.com and schedule yourself a no sweat strategy session where we can talk about what we can do to help you improve your health, help you lose some weight, help you to get stronger, help you to sleep better, help you move better, function better, all those kind of things. So there you have it. Again, I want to thank you for taking the time to listen to what I have to say. I hope it's helpful. And I hope it scared you just enough to exercise if you're not exercising now, and if you are exercising, to keep exercising. So you look for me again next week, where I can give you more information on how to get fit, feel younger, and live better.